Hey, all, Dan here again. Welcome back. We're going to continue talking about head-related transfer functions, HRTFs. Remember, we described what it was. HRTF means head-related transfer function, and a transfer function is simply a recipe. It tells you if you give me an input, this is what you're going to get for the output. So it's an equation. It could be a linear thing like y equals x, or it could be complex, whatever. Doesn't necessarily matter what the transfer function is at this point as you're learning about HRTFs, more that you understand it's just an equation, it's just a recipe of if you give me an input, this is what you're going to get output. So why do we have HRTFs in the first place? Why, sound comes in, why don't we just hear what it is? Why does our head do this weird thing? So I want you to listen to this as I'm talking to you right now. I'm going to continue talking to you, and now what do you hear? You hear a lot more of the low voice, and you hear less of the high registers. It's the same thing like when you're walking into a club or into a music venue, and you hear the boom, 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 you hear the low frequencies, but you don't hear the high frequencies. High frequencies are blocked by sharp angles, by surfaces, things like that. Basically, anything that's bigger than a wavelength it becomes a blockage to the frequency. We'll get into that on the next video. But first, I want you to understand that, you probably experience that walking around as you listen to things, as you go around a corner, people's voices are a little muffled and things like that. And then suddenly when you come around the corner, you hear great. That's because the wall is acting as a transfer function. It's acting as a low-pass filter, things like that. Our head acts as a low-pass filter too. So I've got a couple cool diagrams here. So for instance, this is an overhead view of a head. That's a side view of the head. Yes, I'm a sucky artist. I'm an engineer. Live with it. So this is it. We've got a sound source up here that's coming in. And so as sound comes in, and it comes in and hits this person's head, well, it's a straight shot here. But this ear over here on this side actually has a block, the head in between. So you're not going to get so many of the high frequencies over here. You're going to get a lot of high frequencies here, but not much here. Likewise, if it's up above, hey, it's coming in, it may be straight on axis, maybe right above your head, perfect. Goes to each ear regularly, but your ears have these weird flaps on them called ears, earlobes and things like that. And so that's going to shade some of the high frequencies up here based upon what's going on as well. So you're going to have a different sound. So basically, as sound comes at different directions around your head, in basically this way or around it this way, as the sound comes in, it has different obstacles it's going to encounter to a given ear, partly caused by your ear, its flaps itself, also by your head. And that means that no matter what angle the sound is coming in, it's going to sound different. There's going to be a different transfer function for all those different directions that are coming in. That's what happens. So tomorrow we're going to get into a little more into the the next video, I should say, because it's going to be a weekend for me. This is a Friday, so I'm probably not going to do video this weekend. Aren't you lucky? So the next video we're going to get into what those equations are, how it actually works, how those filters kind of act in. But that's what's happening. Essentially, sound coming into you from different directions, and the shape of your head, the position of the sound relative to your head, and also your ear canal. It's because the sound's coming from behind. I've got these big flappers in the back. I don't have much up front, so it's going to sound different coming here versus from the back, regardless of whether it's, on the same axis or anything like that. So that's going to affect the sound. So remember, all we're doing with an HRTF is we've got these different equations, these different recipes that correspond and tell us, hey, at this angle, and at this angle, this is what happens to the sound. This is how it equalizes off. So next one, we'll get into a little bit more of the math, a bit more of the physics of how that works. And it's generally good for everything that you're going to ever need to do. So check it out. Periodic Audio. By the way, we still have some good deals going on right now. Our Silicon is on Indiegogo. Jump in now if you want to get a stunningly good performing DAC that's, tiny, tiny, tiny. You take it with you everywhere. It's going to sound phenomenal. Check it out. It's on Indiegogo, igg.me/@/periodic. And of course, our website. We've got a lot of good, cool things there right now, too. We've got some cool sales going on right now. If you want a lower cost DAC or our Neon, our Bluetooth adapter, check that out. That'll help with some HRTFs. But anyway, there you go. That's today's lesson. Have a good one. Talk to you later. Bye.